let's get to work. This is Unit 5, Lesson 3, Student-Facing Tasks. In the Google Classroom, it says 8.5.3. This lesson's title is Equations for Functions, and it's a good idea to use a math notebook for taking notes. Please put the title in your math notebook. Equations for Functions. So far, we've learned input-output diagrams, and we've learned what a function is. A function is an input-output rule where each input has only one and exactly one output. Now, we're going to learn that we could use an input-output diagram to show our functions, or we can use equations, which is something that you're already used to. We're going to relate the diagrams to equations. You're also going to learn the independent variable and the dependent variable. Let me just give it to you in advance right now. In the diagram, our input is also called an independent variable. When our input is a variable, that is the independent variable. Go ahead and take the same notes as me in your notebook. There we are. Independent variable goes in. And then we do the stuff in the function rule. And we'll get out our dependent variable, our output. Our output is also called a dependent variable. Try to think of it this way. The output depends on what the input was. The input is independent. It doesn't depend on anything. But the output depends on what the input was. It's the dependent variable. You'll learn independent variable and dependent variable in this lesson. The worksheets that I gave you in class look like this, and you have it on your computer where you need to enter in your answers. So let me help you with that. The first problem says, fill in the table of input-output pairs for the given rule. Write an algebraic expression for the rule in the box in the diagram. Okay, so we have to write an expression for this rule. Input. Let me label this first. The input is S, the side length of a square. And the output is A, the area of the square. Okay, if S is the side length of a square, then what is the area of that square? The table gives us possible inputs, and we have to calculate what the output would be. So this is S, the input, and the output is going to be A, the area of a square. Well, I'm kind of lazy. I like to use a calculator, and I don't mind if you do the same. Okay, so to get the area of a square, we have to square the side length. So that'll be 8 squared, which is 8 times 8, and that equals 64. If the side length is 2.2, then 2.2 squared is the area of the square. 2.2 times 2.2. 4.84. All right, if we have a square with side length of 12 12 1/4, then our area is 12 1/4 squared. I'm just going to use decimals instead of fractions because I'm a little lazy. 12.25 squared is 150.0625. And then I'll go ahead and convert that back into fractions in case I need it in fractions. That's 150 and a 16th. If the side length is S, then the area is S squared. Okay, we did it. We filled in the table of input-output pairs. And let's read carefully. How are we going to report this answer? It says, create and fill in the table using the table button. Remember that the table button is under these 3 dots. Go to this table icon, and then you're going to select a 2 by 5 table. That means 2 columns and 5 rows. Put the heading on those, input, output, and I really hate it that this computer program keeps those boxes exactly where I need to see what's going on. Okay, in the table, the possible inputs, not possible, I mean the given inputs were 8, 2.2, 12 1/4, but I'm using decimals just to make myself more comfortable. And the outputs we calculated were 64, 4.84, 150.0625. And S squared. To do S squared, I'm going to use the equation editor. Let me delete that S. Go to the 3 dots. You can click on this square root symbol to bring up the equation editor. S squared has an exponent. So I'm going to click on this icon here. Then I get S, and I move over to the little box to do a superscript 2. That means S to the power of 2. It'll insert that for me when I click OK. Oops, it did not insert it for me. It deleted everything. What did I do wrong? There it is. I'm going to try that again. Equation editor, superscript, S to the power of 2. OK, there it is. And then I'm going to submit the table. Even though I'm helping you and showing you all the answers during remote learning or asynchronous learning, it's really important that you do this. If you don't have your papers with you, use your math notebook. Draw the table. Square each one of these inputs to get the area. Then submit your answer. Good. Next, it says write an algebraic expression for the rule. Okay, well, the rule is to take the input and square it to get the area of the square. That means the area of the square equals the input squared. Well, this part right here is the rule that should go in the box. It should be S squared. Now, here's something tricky that they don't tell you in the program, so listen up. It says type your answer below. It should be a mathematical expression, but I bet you've never seen this before. I've seen it many times though. When you type in mathematical expressions with powers, like S to the power of 2, you have to use this caret symbol. I bet you've never seen it before, but I want you to get used to it. S caret 2 means S to the power of 2. It means S squared. I don't know why they didn't just let you use the equation editor, but this little box is going to check your answer. So you have to have it in correctly. S, and this is called caret. I know that's funny, just get used to it. The caret button is Shift 6 and then 2. That means S squared. That means S to the power of 2. Just get used to it because you're going to see that a lot more in high school. And click on next problem. We did it. Okay, that page is finished. And here's what you've learned. You've learned that we can represent functions with equations or diagrams. Here is the diagram for this function. Here is the equation for this function, a equals s squared. And now it's time for me to introduce the independent variable and the dependent variable. Look again at this table here. We have numeric inputs, 8, 2.2, 12 and a quarter. Those are numbers. But then we have S. S is a variable. When we use a variable for the input, we don't call it the input variable, but we should maybe. We call it the independent variable. Instead of a number, we're using a variable for the input. So the input variable is called the independent variable. And you've already got that in your notes. The independent variable is the input. But let's look at our equation again. A equals S squared. So the S is the input, the square length. And the A, that is the output. We're going to call the output variable the dependent variable. Input variable is, don't forget, independent variable. Make sure you have this written down right now. And then I'll explain it. The side length doesn't depend on anything. That's just the length of the square. The square has some side length, and we call it S. It doesn't depend on anything. It is independent of anything else. But the area of the square, that depends on the side length. Let me say that again. The area of the square, that depends on the side length. So we're calling that the dependent variable. Independent variable goes in, dependent variable goes out. Okay, let's keep going. Now I'm on the question that you see on the screen. And the directions are match each of these descriptions with a diagram. We have 4 descriptions and 4 diagrams, A, B, C, and D. Notice that the descriptions have a lowercase letter and the diagrams have a capital letter, so we'll match them. On your screen, you see the 4 diagrams, and it's hard to see that this is the description here. They're only showing you A first. So there's description A. I think this program's a little hard to use because it says match each of these descriptions with a diagram, each of these descriptions, but it only gives you 1 description at a time. So if you're just using the program, you don't know that there are 4 descriptions total. Anyway, okay, it says A, the circumference C of a circle with radius R. Notice that when they say circumference, comma, C, it means that's the variable that means circumference. and they have radius, comma, r, it means radius, comma, here's the variable. Okay, look at the boxes, the diagrams. Which one of these diagrams gives you the circumference of a circle with radius r? Well, this diagram says something, the input gets cubed, but that's not how we find the circumference of a circle. And this diagram says 60 times the input, but that's not how we find the circumference of a circle. Circumference of a circle is the distance around the circle. The distance across the middle of the circle is the diameter, and half of that distance is called the radius. So I'm going to draw the radius here. The circumference is the length around the circle. Do you remember pi? Pi is the ratio of circumference to diameter. And I can rearrange this equation to find that circumference equals pi times diameter. The diameter is 2 times the radius. So now I can even write circumference equals pi times 2 times r, because 2r, 2 times the radius, is the diameter. Okay, so now you see that it is D. Diagram D gives you the circumference of a circle as the output when radius of the circle is the input. I'm going to mark that in the table on my paper. So that's description A, it is diagram D. But on your screen, you have to select it. And it tells you you're correct. Okay, B. Description B says, the distance in miles, D, that you would travel in T hours if you drive at 60 miles per hour. Okay, the distance that you would travel in T hours if you drive 60 miles per hour? Well, diagram A gives you the input cubed. That would not give you the distance in T hours. Diagram B, however, says 60 times T. Input times 60. Well, that's it, because the input is the time, and if you multiply the time by the speed of 60 miles per hour, then yes, you get the distance. So description B matches diagram B. You can fill it in on your table and click it on your computer screen. C, the output when you triple the input and subtract 4. Well, we've only got these two remaining, A and C. So it is not the input cubed. Aha, it is the input times 3 minus 4. The input is x. Input times 3 minus 4. That means we've got the output when you triple the input and subtract 4. C is C. And there's only one more remaining, so I'm sure you can figure it out. I'll read it anyway. D, the volume of a cube, V is volume, given its edge length, S. So S is the length. Okay, there it is. The volume is the length cubed. So description D matches diagram A. Something a little difficult about these is that the diagrams stay way up here. You have to keep going up and down to find them. That's why I'm happy to give you the printed papers to help you work faster. Okay, next part, which on your paper is number 2. In fact, I'll switch colors. Okay, number 2 says, write an equation for each description that expresses the output as a function of the input. Let me say that again. It will express the output as a function of the input. So what we want is an equation that gives us output equals something something with the input. Output equals, and then something 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 something. I'm just going to scribble to show something something input. Then the output is going to be the dependent variable, and the input is going to be the independent variable. If that's still confusing, don't worry yet. Don't worry yet. You can just learn a little more before you start to worry. Okay, so we're going to write an equation, and it starts with output equals. And they gave us description A first. Complete the equation below. Use R as your variable. So they have it on the screen to help you. C equals. Your answer is going to be an equation for C equals, and it tells you mathematical expression. Okay, actually that's kind of easy because it's in the box. The circumference of the circle is 2 times pi times the radius of the circle. 2 pi r. Good, I got it correct. So that is the expression for C. I'm going to write it out this way. C equals 2 times pi times r. Description B. Complete the equation below. D equals, so this is for description B right here. What does D equal? Well, this one's also easy because they have it in the box. The distance that you would travel in T hours is going to be your speed, 60 miles per hour, times T, the number of hours you've traveled. I'll put that right down here too. D equals 60 times T. We could show it with a diagram, or we can give this function as an equation. Type in the expression for D, 60T, and submit your answer. Okay, now look at description C. The output when you triple the input and subtract 4. And they give you variables of y and x. So y is the output. I'll do it right here. Y is the output, and y equals, it says triple the input, so that's 3x, and subtract 4. Go ahead and type it in. 3x minus 4. All we're doing is relating the diagrams to equations. Now you see that you can use an input-output diagram, or you can use an equation to represent a function. Let's do the last one, D. The volume of a cube given edge length S. So V, volume, or V equals S cubed. And that's even right here to help you. V equals S cubed. Type in your expression. S, don't forget your caret. Caret 3. I want to make sure you noticed what I typed in, if it's too small on your screen. S to the power of 3. Type it in this way. The little caret means to the power of, and that's how you get S cubed. And this little caret on your keyboard, that is Shift 6. Look for Shift 6, number 6, Anyway, you can do it. Phew! Okay, now we're still going here. We finished A and B. Now, I'm sorry, not A and B. We finished 1 and 2. Now, number 3. Number 3 says, find the output when the input is 5 for each equation. On the papers that I gave you, you can fill in the table. I forgot to do that. I wrote these equations up here. Could you hold on? I'm going to write them again real quick. So for description A, it was diagram D, and the equation is C equals 2 pi r. For description B, the equation is D equals 60t. For description C, the diagram is C, and the equation is y equals 3x minus 4. And for description D, the diagram is A, and the equation is v equals s cubed. Now, we're going to find the output when the input is 5. I think it's easy just to use the equations. That's why I wanted to stop and write them down. Remember that the input is the independent variable and the output is the dependent variable. So for description A, it means the circumference of the circle depends on the radius. When the radius is 5, I'll use a calculator, then 5 times 2, that's 10 pi. I just did 2 times 5. Let me write that down actually. C equals 2 times pi times input is 5. That's how I got 10 pi. 2 times 5. Okay. For B, if you've been driving, oh, I'm sorry, I forgot to submit my answer. It says find the output when the input is 5 for each equation for description A's equation. Okay, so I was going to use pi, but look at the directions. It did not tell me to use pi. Okay, 3.14. Pi is 3.14. So this would be 10 times pi. That would equal 31.4. Let's see what I get. I wanted to leave it in terms of pi. Nope. Okay, 31.4. That's 2 times pi times 5, which equals 10 times pi, which equals 31.4. Okay, got it. Now, description B. What is the output when the input is 5? If the input is 5, that means 5 hours. So that's 60 miles an hour times 5 hours of driving. That's a distance of 300 miles. But it says only type in the number, don't write miles. Let's go to the next problem. Now, description C. Description C says the output equals 3 times the input minus 4. So if the input is 5, that's 3 times 5, which is 15, minus 4. I'll do it on the calculator so you can check me. 3 times 5 is 15, minus 4 equals 11. The output is 11. Type your answer in as a number. One more to go. What is the volume if the side length is 5? Remember, the volume is the dependent variable. It depends on the side length. The side length is the independent variable. So we plug in the independent variable. S equals 5, and then 5 cubed is 125. If you don't believe me, you can check it on a calculator. 25 times 25 times, wait, not 25 times, 5 times 5 times 5, 5 times 5 times 5. There. Oh my goodness, I must be getting tired. I'm going to use the scientific calculator. That would probably be smarter. 5 cubed. There, 125. We're not done. We're almost done with this problem, and then we've got more. Let me submit that answer. Okay, the next part, they're asking what are the independent variable and the dependent variable? Read the question. Name the independent and dependent variables of each question. What is the independent variable in description A's equation? This is terrible, isn't it? If you only had your computer, you'd have to go all the way back up to figure out what was description A. It's right here, the circumference C of a circle with radius R. That's too hard to go around finding it. That's why I gave you the worksheets that go with it. So keep track of what you're doing on your paper as you do it. That's going to help you learn a lot better because you can see the whole picture of what's going on. Anyway, back down. Name the independent and dependent variable. Oh, yeah. Okay, the independent variable in A is the radius. The radius is independent. The radius does not depend on what the circumference is. The circumference depends on the radius. And you can see that too because it is the input. Let me get a highlighter. Right here, the radius is the input. So that can help you if you still find it confusing. And the output is the circumference. So you have to remember, input is independent variable. Output is dependent variable. Okay, next question. What is the dependent variable in A's equation? That's the circumference. Now they're asking about B's equation. I have it here on my paper. B. This one here, distance in miles, it's this one. The independent variable is the time because that's the input. We're inputting the time in order to calculate the distance. And the dependent variable is the distance because the distance depends on the time. Okay, hang in there with me. What is the independent variable in description C's equation? C was this one. This one. I'll fill in the table. The independent variable is x. X. And the dependent variable was y. Read your screen carefully to make sure that you're submitting the correct answer for the correct question. What is the dependent variable in description C's equation? Y. Y depends on x. So y is the dependent variable. One more. D's equation. Okay, go to equation D. Notice that it's the lowercase d, so that means it is this description, not the diagram. Look at the description. Remember that we matched these to the diagrams? Anyway, D's description is diagram A. The independent variable is the length of the side of the cube. The cube's side length doesn't depend on anything else. It's independent. The volume of the cube depends on the side length. So the independent variable is S and the dependent variable is V. I already know the answers and I'm exhausted. You guys are doing great for hanging in there. I'm going to stop this video and take a break before I continue. So the next video is going to be video 2. We're still on the student-facing tasks. Go on now to video 2.